Hello. Hello.
Good morning all. Guests are arriving, so gather at the venue.
Hello.
Good morning all. Guests are arriving, so gather at the venue.
Hello.
Good morning all. Guests are arriving, so gather at the venue.
Hello.
Good morning all. Guests are arriving, so gather at the venue.
Hello.
Good morning all. Guests are arriving, so gather at the venue. Good morning all. Guests are arriving, so gather at the venue. Good morning all. Guests are arriving, so gather at the venue. Good morning all. Guests are arriving, so gather at the venue. Good morning all. Guests are arriving, so gather at the venue. Good morning all. Guests are arriving, so gather at the venue.
ನಿನ್ನೊಡೆಯ ಎಂಬುದು ಜ್ಞಾನರತ್ನ ಅಂತಪ್ಪ ಜ್ಞಾನ ರತ್ನವ ಕೆಡಗುರುಡಿ ಆ ರತ್ನವನ್ನೀನಲಂಕರಿಸಿ ಆದರೆ ನಮ್ಮ ಗುಹೇಶ್ವರ ಲಿಂಗದಲ್ಲಿ ನಿನಗಿಂತ ಸಿರಿವಂತರಿಲ್ಲ ಎಲ್ಲ ಮನವಿ. ಮೈಸೆಲ್ಫ್ ಮಹಾಲಕ್ಷ್ಮಿ ಅರಮನಿ.
Good morning, and myself Shruti Gaikwad from 5th SEM CSE Department would like to welcome you all to this 6 days ATAL FDP on Internet of Things for emerging technical applications. Let us have a virtual tour of our college.
ಸಿರಿವಂತರಿಲ್ಲ ಎಲ್ಲ ಮನವಿ. ಮೈಸೆಲ್ಫ್ ಮಹಾಲಕ್ಷ್ಮಿ ಅರಮನಿ.
Good morning, and myself Shruti Gaikwad from 5th SEM CSE Department would like to welcome you all to this 6 days ATAL FDP on Internet of Things for emerging technical applications. Let us have a virtual tour of our college.
ಮಹಾಲಕ್ಷ್ಮಿ ಅರಮನಿ.
virtual tour of our college.
Thank you so much, KLECET. Thank you.
Now, to add some dignity and fragrance to the dais, it is time to invite our honorable dignitaries to occupy their respected places. Here, I request Dr. S.G. Golgi, HOD of CSE Department and Program Coordinator, to escort dignitaries to the dais. Now, to add some dignity and fragrance to the dais, it is time to invite our honorable dignitaries to occupy their respected places. Here, I request Dr. S.G. Golgi, HOD of CSE Department.
An institution of higher education is a partnership among students and alumni, faculty and administrator, donor and trustee, neighborhood and many more to build a community and a culture. The community plays a very important role in building an institution, the KLE institution.
KLE College of Engineering and Technology Chikkodi has been established in the year 2008 with the sole objective of imparting quality technical education for rural youth. The city of Chikkodi has a strong educational base and enjoys salubrious climate throughout the year.
Our institution is approved by AICTE New Delhi and recognized by Government of Karnataka. It is affiliated to Vishveshwaraya Technological University, Belagavi, the State Technical University of Karnataka. This institute has state-of-art infrastructure and most modern facilities. This institute renders engineering education in 5 undergraduate level program, 2 postgraduate level program and research center. Our institute is recognized as Model Rural Engineering College by VTU, Belagavi.
We cannot be separated in interest or divided in purpose. We stand together until the end.
The CSE department is committed to continuously improve the quality of education by enhancing the knowledge of students and staff, navigating the frontier of innovation, exploring the dynamic realm of CSE department.
In the ever-evolving landscape of technology, the CSE department stands as a bastion of innovation and knowledge, the guidance and cooperation of experienced and expert faculty member of the department, and a strong alumni association are the attracting features we want.
Today, we gather to delve into the release of continuous learning and growth through the faculty development program facilitated by AICTE. AICTE Training and Learning Academy ATAL, the Faculty Development Program on Internet of Things for Emerging Technical Application. The sole objective of ATAL is to impart quality training through faculty development program for postgraduate students, research scholars, and faculty members.
This program is designed to empower our educators with latest knowledge and teaching methodologies.
IoT is the idea of making devices and objects smarter by linking them to the internet.
Foster continuous professional development among faculty members to keep them abreast of the latest advancement in their respective fields.
Establish and reinforce quality assurance mechanism to ensure high standards of technical education, delivery assessment, and accreditation.
Facilitate discussion and workshops to aid in the development and improvement of curricula, ensuring alignment with industry needs and global standards.
By addressing these objectives, the AICTE Training and Learning Academy ATAL for FTC aims to create a dynamic and progressive ecosystem in technical education benefiting both educators and students alike. In the harmonious note of our invocation song, we find the equivalent language that speaks out the soul, unlocking the door of the world where melodies invoke the spirits of unity and celebration. With this, I call upon Miss Lakshmi Hulikoppe and team of 5th Sem CSE department to present invocation song. In the harmonious note of our invocation song, we find the equivalent language that speaks out the soul, unlocking the door of the world where melodies invoke the spirits of unity and celebration. With this, I call upon Miss Lakshmi Hulikoppe and team of 5th Sem CSE department to present invocation song. In the harmonious note of our invocation song,
ಕಲಿಸು ಸದ್ಗುರುವೇ ನೀ ಕಲಿಸು ಕಲಿಸು ಗುರುವೇ ಕಲಿಸು ಕಲಿಸು ಸದ್ಗುರುವೇ ನೀ ಕಲಿಸು ಸುಳ್ಳಿನ ನಡುವೆ ನಾ ಸತ್ಯವನಾಡಲು ಕಲಿಸು ಸುಳ್ಳಿನ ನಡುವೆ ನಾ ಸತ್ಯವನಾಡಲು ಕಲಿಸು ಸ್ವಾರ್ಥದ ನಡುವೆ ನಿಸ್ವಾರ್ಥಿಯಾಗಲು ಕಲಿಸು ಸ್ವಾರ್ಥದ ನಡುವೆ ನಿಸ್ವಾರ್ಥಿಯಾಗಲು ಕಲಿಸು ಅಂಜಿ ನಡೆವರ ನಡುವೆ ಧೀರನಾಗಲು ಕಲಿಸು ಅಂಜಿ ನಡೆವರ ನಡುವೆ ಧೀರನಾಗಲು ಕಲಿಸು ಧರೆಯ ದುಷ್ಟರ ನಡುವೆ ಜಾಗನಾಗಲು ಕಲಿಸು ಕಲಿಸು ಗುರುವೇ ಕಲಿಸು ಕಲಿಸು ಸದ್ಗುರುವೇ ನೀ ಕಲಿಸು ಕಲಿಸು ಗುರುವೇ ಕಲಿಸು ಕಲಿಸು ಸದ್ಗುರುವೇ ನೀ ಕಲಿಸು ಬೆವರಿಸಿ ಗಳಿಸಿದ ಒಂದು ಕಾಸು ಸಿಕ್ಕ ಹತ್ತಕ್ಕಿಂತ ಮಿಗಿಲೆಂಬುದು ಕಲಿಸು ಬೆವರಿಸಿ ಗಳಿಸಿದ ಒಂದು ಕಾಸು ಸಿಕ್ಕ ಹತ್ತಕ್ಕಿಂತ ಮಿಗಿಲೆಂಬುದು ಕಲಿಸು ಸೋಲು ಗೆಲುವಿನಲ್ಲಿ ಸಮಚಿತ್ತದಿಂದಿರಲು ಸೋಲು ಗೆಲುವಿನಲ್ಲಿ ಸಮಚಿತ್ತದಿಂದಿರಲು ಶತ್ರುಗಳಿಗೂ ಸನ್ಮಿತ್ರನಾಗಿರಲು ಕಲಿಸು ಶತ್ರುಗಳಿಗೂ ಸನ್ಮಿತ್ರನಾಗಿರಲು ಕಲಿಸು ಹಸಿರು ಮನೆಗೂವಲಿನ ಧ್ಯಾನಿಸಲು ಕಲಿಸು ಜಾಣನಾಗಲು ಕಲಿಸು ಕಲಿಸು ಗುರುವೇ ಕಲಿಸು ಕಲಿಸು ಸದ್ಗುರುವೇ ನೀ ಕಲಿಸು ಕಲಿಸು ಗುರುವೇ ಕಲಿಸು ಕಲಿಸು ಸದ್ಗುರುವೇ ನೀ ಕಲಿಸು
Thank you, Lakshmi and team.
Welcome is not just a word, it's an embrace that transcends boundaries. In every welcome speech, we craft bridges of warmth, inviting others to step into a space where hospitality reigns and connection flourish. So, I request Dr. S.J. Golgi, HOD and Professor of CSE Department, to present welcome speech.
Welcome is not just a word, it's an embrace that transcends boundaries. In every welcome speech, we craft bridges of warmth, inviting others to step into a space where hospitality reigns and connection flourish. So,
Good
I
morning,
request
ladies and
Dr.
gentlemen.
S.J. Golgi,
It's my
HOD and
privilege
Professor of
to stand
CSE
before you all
Department, to
on the
present
auspicious
welcome
occasion of
speech.
inaugural function of Faculty Development
Welcome is
Program
not just a word,
on
it's
IoT
an
for
embrace that
Emerging Technical
transcends
Applications
boundaries.
sponsored
In
by
every welcome
AICTE
speech,
Training and
we
Learning
craft
Academy, New
bridges of
Delhi,
warmth, inviting
organized by
others
CSE
to step
Department,
into a
KLE College
space
of
where
Engineering and Technology,
hospitality
Chikodi.
reigns and connection
Respected
flourish.
dignitaries
So, I
on and off the
request Dr.
dais,
S.J.
esteemed
Golgi,
participants,
HOD and
research
Professor of CSE
scholars,
Department,
experts,
to present
heads of
welcome
various
speech.
sections, and dear students.
Welcome is not
I
just a
take this
word,
opportunity
it's an
to
embrace
extend
that
a
transcends
heartfelt welcome
boundaries.
to
In
the Chief
every
Guest of
welcome speech,
inaugural
we
function,
craft bridges of
Dr.
warmth,
Rajkumar Patra,
inviting others
Professor,
to step
CMR
into a
Technical
space
Campus,
where
Hyderabad.
hospitality
I
reigns and
wholeheartedly,
connection
on behalf
flourish.
of
So, I
entire
request Dr. S.J.
KLECET
Golgi,
family,
HOD
I
and
welcome
Professor of
Rajkumar
CSE
Patra.
Department, to
Welcome you.
present welcome speech.
Further, I am truly honored to welcome the organizing chairman of this FDP and our beloved principal, the backbone of FDP, Dr. Prasad Rampure sir. Welcome you, sir. I extend a warm welcome to my colleague, Dr. Bahubali Akiwate, co-coordinator of the FDP. Welcome you, sir. I offer a gracious welcome to esteemed participants, research scholars, heads of all the sections, and students. Welcome you all. So now, as the coordinator of ATAL FDP, so I would like to say a few words regarding FDP. So as you know, this 6 days FDP is planned with around 16 sessions, out of which 2 sessions are practical and remaining 14 sessions are theoretical, with a range of basics of Internet of Things to some advanced topics, including deep learning in IoT, then cloud computing, especially edge computing in IoT, and AI/ML in IoT analytics. And apart from this, we will have an industry visit to ACRES Private Limited, Special Economic Zone, Belgaum on Friday. Full day is there. So this FDP aims to equip us with the skills, insights needed to navigate the intricacies of IoT and its applications in emerging technical domains. Moreover, this FDP encourages interdisciplinary collaboration and exchange of ideas among faculty members. So this cross-pollination of knowledge not only enriches individual teaching practices but also promotes a holistic approach to education. The diverse expertise in this room promises a rich learning experience, enabling us to envision innovative solutions and contribute meaningfully to the ever expanding field of IoT. May this FDP serve as a catalyst for transformative insights, forging connections that extend beyond these sessions. I wish you all a rewarding and enlightening experience toward this FDP. Thank you. Thank you very much.
Thank you, sir. Presenting flowers is like offering a nature's beauty, a grand gesture that speaks louder than speaking a single word. I request Dr. Prasad Rampure, Principal KLECET Chikodi and Chairman of today's function, to present bouquet to our today's chief guest, Dr. Rajkumar Patra, CMR Technical Campus, Hyderabad, as token of love and respect. A grand gesture that speaks louder than speaking a single word. I request Dr. Prasad Rampure. Thank you, sir.
Further, I request Dr. S.J. Golgi, HOD and Professor of CSE Department, to present bouquet to Dr. Prasad Rampure, Principal of KLECET Chikodi, as a token of love and gratitude.
Grand gesture that speaks louder than speaking a single word. I request. Thank you, sir. Now I request Dr. Bahubali Akiwate, co-coordinator of today's function, to present a bouquet to Dr. S.G. Golgi, HOD of CSE Department, KLECET Chikodi, as a token of love and respect. Thank you, sir.
I request
Thank you,
Dr.
sir.
Sanjay
Now I
Antli,
request
Training and
Dr.
Placement Cell
Bahubali
Officer of
Akivate,
KLECET
co-coordinator of
Chikkodi,
today's
to present
function, to
bouquet
present
to
a
Dr.
bouquet to
Bahubali
Dr.
Akivate,
S.G. Gulgi,
co-coordinator of
HOD
the
of CSE
function, as a
Department,
token of
KLECET
love and respect.
Chikkodi, as a token of love and respect. Thank you, sir. Lastly, I request angels to present flowers to exam dean, academic dean, and various department HODs as a token of respect and gratitude.
Co-coordinator of the function, as a token of love and respect.
As a token of love and respect. Thank you, sir. Lastly, I request angels to present flowers to exam dean, academic dean, and various department HODs as a token of respect and gratitude.
Co-coordinator of the function, as a token of love and respect.
Thank you, angels. As the delight caretaker of our botanical companion, let us embrace the sacred beauty of watering plant, a ritual that fosters the flourishing tapestry of life. Each droplet echoes the harmonious rhythm of nature's grand design. I request all the dignitaries on the dais to water the plant. Angels. As the delight caretaker of our botanical companion, let us embrace the sacred beauty of watering plant, a ritual that fosters the flourishing tapestry of life. Each droplet echoes the harmonious rhythm of nature's grand design. I request all the dignitaries on the dais to water the plant. Angels. As the delight caretaker of our botanical companion, let us embrace the sacred beauty of watering plant, a ritual that fosters the flourishing tapestry of life. Each droplet echoes the harmonious rhythm of nature's grand design. I request all the dignitaries on the dais to water the plant.
Thank you, everyone.
As the delight caretaker of our botanical companion, let us embrace the sacred beauty.
A beacon of wisdom, inspiration, wealth of experience that lights the path for all of us. To introduce about the great personality sitting amidst us, I call upon Dr. Sanjay Antli, Assistant Professor of KLECET Chikkodi. Thank you, everyone.
Very good morning.
A beacon of wisdom, inspiration,
Very good
wealth
morning,
of
everybody.
experience that lights the path for all of us. To introduce
Respected
about the
Chief
great
Guest of
personality
Inaugural
sitting
of
amidst
ATAL
us,
FDP,
I call
Dr.
upon
Rajkumar
Dr.
Patra
Sanjay
sir,
Antli,
President of
Assistant
today's
Professor
function,
of KLECET
our beloved
Chikkodi.
Principal sir,
Thank you, everyone.
Convener and HOD of CSE Department, Dr. S.G. Gulgi sir, Co-Convener, Dr. Bahubali Akivate,
A beacon of
Academic
wisdom,
Coordinator,
inspiration,
Exam
wealth of
Coordinator,
experience
heads
that
of all
lights
the
the path for
departments,
all of us.
last but not the least, Respected faculty Chief Guest of participants from Inaugural various of institutes. ATAL FDP, A very good morning. It gives me immense pleasure in introducing today's esteemed Chief Guest, Dr. Rajkumar Patra sir. I start with his education details. Sir has completed his BE in Computer Science Engineering from Karnataka University, Dharwad, MTech from SVTU, Bhilai, Chhattisgarh, and completed PhD in Computer Science Engineering from Dr. C.V. Raman University, Bilaspur. Sir has a professional association with ISTE, Computer Society of India, and IEEE. Coming to his work experience, Sir has a vast experience of 22 years in teaching and research. He has worked as an assistant professor, associate professor in various reputed institutes like RIT Raipur, SSCET Junwai, Rumta Engineering College Raipur. Now he is currently working as associate professor in CMR Technical Campus, Hyderabad. Sir has 2 Australian patents granted in his name with the following titles. The first one is lymph node metastasis detection from CT image using deep learning, which was granted in the year 2020 by Australian Patent Office. The second title is smart shutter assembly system, which was granted by Australian Patent in the year 2021. Sir has published 4 other patents and waiting for FER. Coming to the research publications, Sir has more than 50 research articles published in various reputed national and international journals, with more than 12 papers being indexed by ESCI, SCI, and Scopus database. Coming to the books published by Sir, he has contributed 7 book chapters in reputed books in the domain of biometric authentication, pattern recognition, machine learning, cognitive behavior, human-computer interaction. Sir has attended and presented papers in more than 20 international conferences. He has more than 9 MOOC certifications and delivered guest lecture in various workshops and FDPs in the topic machine learning, artificial intelligence, blockchain, Python programming. Sir has effectively delivered additional responsibilities such as IQSE coordinator, Dean Learning Resource Development, NBA coordinator, and training and placement officer. Sir was appointed as a judge for 2 seasons of grand finale of prestigious Smart India Hackathon in the year 2018 and 2020. Coming to the awards and achievements, Sir has got Best Paper Award in EPPCSIT 2009 held in Guru Nanak Dev Engineering College, Ludhiana for the paper entitled Modeling and Simulation of Gait for Abnormal Foot Recognition Using Neurogenetic Approach. He also received Best Paper Award in ICSCI 2010 held at Dr. MCR HRD Institute, Hyderabad for the paper titled Anomaly in Foot Recognition through Hum Gait Using Hybrid Approach. He was awarded with the certification of merit for scoring highest marks in 4th semester MTech. In the year 2021, Sir Aurobindo Yoga and Knowledge Foundation has recognized him as an innovative academician. Sir shows immense interest in teaching core CSE subjects like data structures, computer organization, analysis and design of algorithm, computer graphics, computer organization, software engineering, problem solving using C programming, object-oriented programming using C++, microcontroller, parallel computing, multimedia technology, artificial intelligence, digital image processing. With this brief introduction, I present before you Dr. Rajkumar Patra sir. Sir, welcome you. Thank you.
Thank you, sir. In the symphony of ideas, our chief guest, Dr. Rajkumar Patra, takes the stage, conducting a profound discourse that echoes with wisdom. As we listen to the melody of insight, may the notes of inspiration resonate, leaving an incredible mark in our minds and heart. I request Dr. Rajkumar Patra, CMR Technical Campus, Hyderabad, to speak few words and enlighten our path.
Hello, very good morning to all. Respected Principal Sir, Coordinator of the program, Dr. Golgi Sir, Co-Coordinator Sir, and the dignitaries of the dais, respected participants, and my dear students. So, it's a great event. So, it's a great initiative taken by AICTE to conduct the FDPs for in the field of the upcoming technologies. So, although the institution has come up with a good topic, that is IoT in IoT applications. So, all of us know what is IoT. So, in these 5 days, we will discuss all the resource persons who are going to deliver their thoughts and share their thoughts. So they will provide some insight into the IoT, and it may be helpful for the participants to go through that, and it may provide some of the research areas, in which you can work out and you can achieve the results. So according to my career, so I have worked in IoT field since 2016. So I have started working. So in this, it is quite interesting. So if you know the basic knowledge of the electronics, so it will be very good for the product development or prototype development, because it is more towards this. This domain is more towards electronics, but nowadays this domain is moved towards the computer science and engineering, because most of the activities, all the things are available, that is in the market, all the sensors, whatever the IoT devices, it is readily available. So just we need to customize. So for the customization purpose, we need to know the basic coding. So if the basic coding part is taken care, then you can come up with the prototypes that can helpful to solve the societal problems. So societal problems means whatever the problems that are around us. So to solve those problems, we can use these technologies, and this IoT technology is very much helpful in solving the societal problems. So I have guided some of the students at my institution. They have come up with some products in the IoT, and those were presented in the national level competitions, that is in SIH, Smart India Hackathons. And they have represented the institution, and some of them are also got awarded. So if the students are going to take up some insight of the IoT technologies, it will be helpful for their future aspects. So with these words, I'll thankful to the organizers for providing me an opportunity to share my thoughts. So I think these 6 days will be fruitful for all of the participants, and they will gather some knowledge and various domains in the IoT field. Thank you. Thank you all.
Thank you so much, sir. I request all the dignitaries on the dais to felicitate our today's chief guest. Thank you, everyone.
In the tapestry of leadership, the presidential remark is a thread of guidance and vision. I request Dr. Prasad Rampure, Principal of KLECET Chikkodi, to give presidential remark.
A very good morning to everybody. Dignitaries on the dais, Dr. Rajkumar Patra, Dr. Gurgi, Dr. Akivete, our next resource person, Srimati Hanji, my dear colleagues, dear participants, and my dear students. In fact, the coordinator forgot to mention that this ATAL FDP, our college was selected as one of the college in the entire North Karnataka. So a lot of efforts have been made for this, and I'm happy that participants all over, not only Karnataka, even people from Tamil Nadu have come, and hopefully the resource person are very, very good. So I can only tell all the participants to make the best use of it. We have also had arrangement to take you to AICTE. AICTE, everybody knows that it is one of the world's recognized SEZ, where a lot of good things are happening. So you can go there also, see everything. And this 6 days you can make the best use of it. I have also given the opportunity to my students, local students, to attend this particular thing. And I will also request the coordinator to, if possible, the resource people like Madam, Sir, if you can take another class for our students, that will be fantastic. So I can only wish the everybody a pleasant stay here. Thank you.
Thank you, sir. Mother India, the timeless nurture of diversity, cradles a symphony of cultures in her embrace. Her landscape whispers tales of resilience, and in heart beats the spirit of unity, saluting the essence of a nation that we proudly call home. Please stand up for the Rashtrageet. एक साथ राष्ट्रगीत शुरू कर.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मांगे। गाहे तव जय गाथा जन गण मंगल दायक। जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
This AICTE Training and Learning Academy, let us embark on the journey ahead, armed with knowledge, inspired by innovation, and united by commitment for academic excellence. As we continue to grow and learn, we hand over the hosting to Session Department.
Hello. Hello. A pleasant morning to one and all present over here. I, Sakshi Nayak from 5th SEM CSE Department and I, Sneha Shiratti from 5th SEM CSE Department are present before you to take you through a knowledgeable journey. The first session to be held is on the topic Introduction to Internet of Things and IoT Technologies by Dr. Rajkumar Patra from CMR Technical Campus, Hyderabad.
The internet is crucial for global communication, access to information, online education. It connects people worldwide, facilitating collaboration, knowledge sharing, and economic growth. Today, to enlighten us about Introduction to Internet of Things and IoT Technologies, we would like to invite Dr. Rajkumar Patra from CMR Technical Campus, Hyderabad.
Hello. Yes, good morning to all. So thank you very much for providing me an opportunity to share my experiences about the IoT technologies. So I am going to speak about the introduction part of the IoT technology. What is IoT? What are the things? What are the applications that currently we are using IoT? So in that regard, I'll try to anyway time is running out. So I'll try to short my presentation. So before going to discuss what is IoT, so just I want to make this session interactive. So participants are there, faculties from other institutions and the students of the computer science all are available. So I would like to ask one question to all of you, that is, all of you are using IoT in daily life? So what sort of IoT you are using? What sort of IoT technology you are using? Yes, exactly. Madam has informed that you are using mobiles, the smartphones. So smartphones are nothing but it's a hub of the IoT. It's a hub of IoT. Whatever the information you ask, whatever the things you want to do, you can do with the help of the cell phone nowadays. Because the phones earlier the cell phones are used for the voice communication. Now the cell phones are becoming smart. Smart means they have provided embedded with a lot of things, lot of sensors, lot of information is available. So that's why you can call the mobile phone or the smartphones nowadays as a hub of IoT. So this you can see here. So this is a cell phone which consists of lot of information. It is going to provide lot of information. So to provide the lot of information about the surrounding, it is provided with some of lot of sensors. The sensors are built into the smartphones. So you are having camera, you are having temperature sensor, voice sensor, touch sensor, image sensor, lot of things are available. Yeah. So if you are nowadays in the world, every individual is using IoT in their daily life. That is nothing but the smartphones. Clear? Now I'll move to the topic what I am going to discuss. So the agenda of today's presentation is overview of IoT, then what are the key components in IoT technology, then what is IoT architecture, then what are the benefits we are getting out of IoT, IoT applications, then what are the different challenges, and what is the future trend. So these are the topics of the today's presentation. So first I'll go with the definition for IoT. So as all of us know that IoT stands for Internet of Things. So what exactly Internet of Things? So some participant faculties, they might have handled this subject for the students. What is the meaning exactly Internet of Things? Yes, madam? Things which are connected to the internet. So things means it can be anything. It can be anything. So that means this table or chair can be connected to internet. If we provide certain technology or we can make it as technology enabled. So this can be also connected to the internet. That means by sitting at a remote place, you can visualize what is the position of this chair if you provide proper arrangements. So that is called as the Internet of Things. So this Internet of Things concept is evolved in the year 1999. This concept was evolved in the year 1999. So before this, the connectivity was there. Before 99, the connectivity was there. That is in late 80s and 90s. The connectivity among the devices were there. Clear? So the devices were, in that case, the connectivity was particular. That means you can connect a device which is capable of processing the information. So that is in the late 80s and 90s. So in that regard, I will discuss the evolution of the IoT, how this IoT is evolved. So this is Internet of Things refers to the network of interconnected physical devices, vehicle, appliances and other objects embedded with sensor, software and network connectivity, allowing them to collect and exchange data. So here everything is covered. If you talk about any device, anything in this world, so if you connect everything, so that will be called as your Internet of Things. So things means anything. It may be a physical component, it may be a vehicle, it may be a appliance, anything. So this is the formal definition for IoT. So there may be several other definitions also. So this is the evolution of the Internet of Things. So the first phase is pre-internet. So this was the pre-internet, that is prior to 1980s. Prior to 1980s, the communication was just human to human. Human to human means the telephone system was there at that time. So the humans or the individuals are used to communicate with others through the telephone system for a distance place. Then the next phase is your internet. This internet phase is evolved during the late 90s, late 80s and 90s, when the standardized protocols has been come up. So we have connected the components and the communication is possible. That is called as your e-communication. So during this phase, one of the concept was evolved, that is called as the WWW, that is World Wide Web and the internet. And this was possible due to the research done by the ARPANET. So this internet is come up with from the research agency that is called as the ARPANET. You might have all studied ARPANET. Then after that, in 1999, so this is all about the first phase, that is the internet, World Wide Web. Then the Internet of Things. So this Internet of Things was developed in the year 1999 and it was developed by a British technologist, Kevin Ashton. And he has, while working in Auto ID lab, he has come up with this concept and he has proposed that in the future all the devices can be connected to each other. So from that the concept was evolved, that is called as the Internet of Things. And this Internet of Things was started by Kevin, and it was started from the sensor that is called as your RFID, radio frequency identification. The first phase of IoT development is started from the RFID, that is radio frequency identification. So by using this RFID, each object, whether it is a appliance, whether it is a device, whether a human person, anything will be provided with an identification number, and that RFID is going to recognize that object in the internet by using the radio frequencies. Then the consumer Internet of Things was evolved, that is in the phase in 2010, near about the year 2010. So this was evolved, and the major player at that time was Amazon. During 2010, the Amazon has started this IoT technology to build up the business, that is the consumer business, that is called as your e-commerce. So companies like Nest, Fitbit and other played a significant role in bringing IoT into the mainstream. So this was during the 2010. Then this is the latest IoT, where everywhere you will find the application of IoT. Whatever the sector you name, you are going to find the application of IoT, whether it is agriculture, healthcare, transport, everywhere you are going to find out the IoT. Clear? So this is industrial IoT, that is IIoT, industrial Internet of Things. Similarly, in health also IoT is applied, so that is called as your health IoT. So lot of sectors, they are just coming, applying the IoT technology to increase the productivity and the efficiency level. Clear? And this IoT technology is being standardized after 2010. It is being standardized by the ITU and IEEE. Lot of standards has been provided for the IoT technologies. So to build the prototypes. So these are the various phases, that is generate, collect, analysis, act and visualize. So now the IoT technology is moving in a fast manner, and now the IoT technology is being combined with some of the other technologies, that is your AI, because IoT is a hardware connectivity. IoT provides the hardware connectivity. So now the scientists are working to provide the intelligence into that hardware so that the human intervention will be reduced. So that is called as the IoT with AI and IoT with machine learning. So a lot of technologies are being coming up. So one of the example is the smart city. One of the example is the smart city. So by using this IoT based applications everywhere and providing AI to those IoT based applications for the sustainability and for the environment. So now the smart cities are coming up. So in the early 2000, this IoT technology is fully implemented in a city called as Zurich. It's not in India, Zurich. And Zurich is the first smart city in the world. And it is ranked with A. It is ranked with A. So if you, sometimes it may be possible that some of us may visit Zurich city. So if you visit, you will find that you don't have any problem in visiting the city, various places, because everything is systematic. The transport system, the drainage system, waste collection, waste management, and it's a clean weather, environment is very clean. So all the things are taken care by the IoT technology to provide a sustainable environment. Clear? So by using this IoT technology, the sustainable environment will be created, because I'll discuss some of the applications, how it is helpful in the sustainable environment. So this is all about the evolution of the IoT technologies. Then these are the components of the IoT ecosystem. So when you are talking about a system, IoT technology or system, so these are the main components. So the end is the user. The end is the user, then IoT device, network, security, gateway, cloud and applications. So these are the key aspects of the IoT ecosystem. Then the building blocks. So when you are providing any solution for any problem by using the IoT technology, so these are the basic building blocks for any application. So it starts with the end devices. Then the next one is the gateways, then the network infrastructure, then cloud infrastructure. So end devices means here you are going to find out the hardware components which is going to provide the information about the environment or the surrounding. So it may be a sensor, it may be an actuator, it may be a camera, or it may be anything which is going to provide certain information about the surrounding. So that is called as your end device. It may be a temperature sensor, it may be some other sensor, humidity sensor or anything. Then the gateways. So gateways means these are nothing but so I'll discuss these end devices. So possible end devices in IoT are sensors, objects, RFID tags and actuators. So these are the various end devices. So under sensors, we are having different types of sensors which is going to provide different types of information. So these are the various sensors. So acoustic sensor, vibration sensor, vision sensor, electromagnetic sensor, motion sensor, chemical sensor, temperature sensor, humidity sensor and proximity sensor. So you will find all these type of sensors in your smartphone. Yes or no? If you go through, it may not be visible, but you will find all the sensors in your cell phone. So these for sense the surrounding, so a lot of sensors are available. So temperature sensor, so it is going to provide the temperature of the surrounding. That means if you open up your cell phone, you can visualize the temperature of the surrounding, 23 degrees centigrade, 30 degrees centigrade. So that is due to this sensor. This sensor is available in your cell phone. That's why you are getting the temperatures regularly. So there are various technologies used for the temperature sensor. One is the thermocouples, thermistors, RTDs and infrared sensors. So these are the various technologies that are being used for the temperature sensor. Similarly, these temperature sensors nowadays are available in the thermometers. So during COVID, the thermometers has been used to detect the temperature. So those are called as your optical thermometers, through which you are going to get the temperature from a distance. Clear? Then the temperature sensor applications. So this is used for climate control, industrial process, healthcare, agriculture, weather stations. So you will find the temperature sensor applications everywhere. That is climate control. So for climate control purpose, this sensor is being used continuously to monitor the temperature of the surrounding. Then industrial process, in industries also, so the temperature sensors are being used to control the temperature, whether the temperature is low, high, according to that the proper care will be taken. Then healthcare, so in healthcare also, in the hospitals you will find these temperature sensors, and you will find at home also. So at home also you will find, because when you are using the ACs, so the AC remote is provided with a temperature sensor, so which is going to tell what is the temperature inside the room. Clear? Then agriculture. So in agriculture also, these sensors are being used to monitor the temperature of the surrounding and what is the temperature inside the soil, so that the crop management can be done in a proper manner. Then weather stations. So weather forecast stations also are using the temperature sensors to monitor the temperature continuously. So these are some of the applications of the temperature sensor. Then the gas sensor. So nowadays these gas sensors are used very frequently every places, in all the buildings and in hospitals, at home automation also these gas sensors are being used, because if a particular room is closed for a long duration, a lot of unwanted gases will be deposited. So at that time these gas sensors will be helpful to detect that whether the harmful gases are available inside the room or not. So all sort of things will be detected and proper care can be taken. So some of the sensors are going to detect the harmful gases such as carbon dioxide, methane, carbon monoxide, ammonia, and various organic compounds. Some of the sensors are provided with some special features so that they can able to detect the harmful gases. Clear? So these are the application of the gas sensors: industrial safety, environmental monitoring, smart homes, agriculture, healthcare. So you will find this gas sensor application in every sector of the life. Then alcohol sensor. So nowadays this sensor is being widely used as the guidelines from the transport ministry. So this is used very frequently by the police department. Alcohol sensor, it is going to detect the percentage of the alcohol available in the surrounding. What is the alcohol particles that is available in the surrounding? So that will be detected, and it is going to provide whether it is above the permissible limit or below permissible limit. So for this purpose, so the alcohol sensors are being used. So these are used in breath analyzers, industrial safety, smart vehicles, and smart homes. Here one example is given: smart vehicles. Smart vehicles, nowadays the new vehicles which are coming, the top end vehicles. So if you enter with drunk, so it is not going to start. The engine is not going to start. If the driver is consumed alcohol, and if the alcohol level is below the permissible limit, then only it is going to start. And if it is above the permissible limit, then the engine is not going to start. So this is how the smart vehicles are going to work with the help of the alcohol sensor. Then smart homes. The smart homes also, it is going to detect if function is happening in a house, if anybody came with a drunk, then it will inform that some person has come up with a drunk which is above the permissible limit. So it is going to create for the smart homes. For smart homes also it is required. Then rain sensor. So these are the sensor which are going to detect what is the amount of rain that is being happened. So to calculate the rain amount, what is the rain happened in a particular place, so the rain sensors are being used. So the rain sensors are going to use different technologies. So capacitive sensors, optical sensor, acoustic sensor, and tipping bucket sensors. So these are some of the technologies used for recording the rain amount that has been happened in a particular area. So the application of the rain sensors, it is in agriculture, smart cities, environmental monitoring, and home automation. So these are some of the applications where you can use the rain sensors. Then proximity sensor. So this proximity sensor is going to provide you the information about the objects. What is the position of the objects? So to detect the position of the object, so the proximity sensors are being used, and the proximity sensors are going to use the various technologies, that is infrared sensors, ultrasonic sensors, capacitive sensors, and electromagnetic sensors. Clear? Then the applications. So smartphones and tablets, smart homes, industrial automation, retail, and automotive. So these are some of the application areas for the proximity sensor. So in smartphones, you can calculate the distance. So you might be using the Google Maps. So the Google Maps are going to calculate the distance by using this sensor. Clear? Then smart homes, then industrial automation also, these are required in the assembly line where the product is reached. What is the position of the product? So to identify that, the proximity sensors are being used. And in automobile or automotive, so these sensors are being used for the parking purpose. So when you are reversing a vehicle, so if the object is behind, nearer to the vehicle, so you are going to get the alerts, buzzers in your vehicle. So that is due to this proximity sensor. So in the bonnet you will find some sensors are inbuilt. back side. So when you are doing reverse, so these sensors will be activated and they will record the position of the object in the back, and they will create the alerts according to that. If it is very nearer to the object, then they will create the alerts. Then the optical sensor. So this optical sensor is designed to detect and measure lights of the electromagnetic radiation. So these optical sensors are used for detecting various ambient light sensing, color detection, and object recognition. That means what is the color of the light, what is the surrounding light. So all these things will be recorded or detected by using the optical sensor. So these are the various technologies that are used for the optical sensor, that is photodiodes, photometric sensor, image sensor, infrared sensor. Then these are the applications of the optical sensor. Then the actuators. The next key component is the actuator. So the sensor is going to sense, or it is going to collect the information about the surrounding. But after getting the information, what action to be taken? So that will be performed by another component that is called as your actuator. So actuator is a device that is responsible for taking the action based on the data it receives from the sensor or a central control system. So the sensor will collect the data about the surrounding. Then after getting the data, what action is to be taken? So that will be done by the actuators. So there are a lot of actuators available. So one is your hydraulic actuator, pneumatic actuator, electrical, thermal, and magnetic. So these are the some technologies used for the actuators. So we'll discuss different types of actuators. So one is your electric motor, then servo motors. So these electric motors are applied in the robotic device, robotic system, automated blinds, and smart appliances. So these are the application of the electric motors. Then servo motors, they are used in the robotic camera systems and other applications requiring precision motion control, where the motion is a big factor. The motions are become a big factor. There you are going to use the servo motors. That means in the CCTV cameras, you will find these servo motors. The CCTV camera which is moving for a particular angle. So there you are going to use the servo motors. Then solenoids. So these are found in the devices like door locks, valves, and various industrial applications. When you are designing for a smart door, so in a smart door, this type of actuators are being used. Smart door means when you are entering, so by seeing the motion of an individual, the doors are going to open. So that is called as your smart door. So there you are going to use a actuator that is called as the solenoid actuator. Then hydraulic actuator. So this type of actuators are being commonly used in the machinery applications, that is machines and industrial automation system. We are going to find out such type of hydraulic actuators. Then pneumatic actuators. So these are used in robotics, automated manufacturing process and control system. So these actuators are going to provide precision motion for the robots in the industry. Then piezoelectric actuators. So these are very precision actuators. Piezoelectric actuators are very much precise actuators which are used in the medical applications. Because in the medical application the precision matters. So for precise movement, so this type of actuators are very much useful. So in medical applications we are going to use this type of actuators. Then rotary actuators. So these are used in the robotic joints. So this type of actuators are mainly used in the robotic joints and automated steering system. So in automated steering system means the autonomous vehicles. In autonomous vehicles, whatever the steering is provided, so there you are going to find out such type of actuators, which is going to operate through the control, machine control. So these are several actuators that are being used in the IoT systems. Then the next key component is your boards, whatever the microprocessor or the microcontroller boards that we are going to use for the IoT applications. There are majorly two boards that are being used. One is called as the Arduino and the second one is the Raspberry Pi. So these are the two microcontroller boards that are being used for the IoT applications. So this is the Arduino board. So this is the Arduino board, that is Arduino Uno. So similarly, Arduino come up with lot of variants. So the variants are specified here. Arduino Nano, Mega, Micro, Leonardo, Duo, Shield, Liliad, Bluetooth, Decimilia, Robot Zero and Pro Micro. So these are the various variants of the microcontroller boards that is provided by Arduino. Based on the application, you have to choose these boards. Not required that you can choose Arduino Uno for every applications. Based on your application, you have to choose any one of the board, and this is the pin out diagram for the Arduino board, basic pin out diagram. Then the next one is the Raspberry Pi. So this Raspberry Pi is a foundation based on UK and it was launched in the year 2012. So since then they have released some variants for the Raspberry Pi boards. So these are the various variants for the Raspberry Pi. Raspberry Pi 0, Pi 1, Pi 2B, Pi 3, Pi 4B and Pi 4B. So this is not Pi 4B, this is Pi 400. The last one is Pi 400. So which is the latest microcontroller board from Raspberry Pi. That is Raspberry Pi 400. So this is the connections, how you can make the connections with the Raspberry Pi board. And this Raspberry Pi operates with a operating system that is called as Raspbian OS, which is a Linux variant. That means you can run this board with Linux operating system. And it supports the Python language also. You can program your application by using Python programs also. Then the gateways. The next component of the IoT system is the gateways. So the gateway may be a software component or it may be a hardware component which is going to provide the connectivity between the internet and the end devices, which is going to provide a connectivity between the internet and the end devices. So that's why sometimes it is called as your edge devices. These gateways are sometimes called as the edge devices because they are in the edge between the internet and the end user. Clear? So these are the functionalities of the gateways. Establishing communication bridge, provides additional security, performs data aggregation, pre-processing and filtering of data, provides local storage, data computing at edge level, ability to manage entire device, device diagnostic, adding more functional capability, verifying protocols. So at the edge, before providing the connection to the internet, so it may perform some other functionalities. That means whatever the sensor data is collected, so that may contain some noises. So the filtering of the noises also can be taken care by the gateways. Similarly, it performs some sort of data analysis also and it provides some security levels also. So these are various functionalities for the IoT gateways. Then the network connectivity. The next component in the IoT system is the network connectivity. So to provide network connectivity, several technologies and the standards are being used. So nowadays the Wi-Fi technology is being used. Now Wi-Fi may be 2G, 3G or 4G. But till now the IoT devices are not been communicating using the 5G. Still the work is going on. So that is the latest research topic, how the IoT devices can communicate using 5G technology. So that is not done till now. So apart from that, so it is going to use some other network terminologies, network facilities, that is communication modes, that is Bluetooth, Wi-Fi, LoRa, Zigbee, Z-Wave, Sigfox. So these are some of the communication technologies that are being used in the IoT application, IoT based applications. So these are some of the connectivity options that are available. Then the cloud-based applications. The last key component is the cloud-based application. So instead of using the IoT application standalone, it is better to use a cloud-based application. So because it will store the historical data, and based on the historical data, it can do some data analytics and it will provide better decisions. So to get the better decisions in case of IoT technology, now the cloud infrastructure is being embedded, and that is the last step. So where all the sensor data will be stored into the cloud, and some algorithm will run, data analytics algorithm will be applied on those data, and they are going to provide some better decision making capability, so that the devices or the IoT technology will provide better results. So in this field, the various cloud service providers, they are providing a lot of applications, that is AWS, that is Amazon Cloud Services, then Microsoft Azure Cloud, they are providing various services for the IoT applications. Of course, it is on paid basis. You will not get any application from Amazon or Microsoft on free. So these are some of the application storage of a cloud. Then the cloud based application, this is one of the example of smart home. It is a cloud based application, so you can monitor your house or home by using this application, and this application is provided by Amazon. This particular application is provided by Amazon. So if you download this application and if you pay, you can automate your house and home, and you can monitor this. Then the architecture. So the architecture of the IoT is divided into 4 stages. One is called as the sense layer, second one is the data acquisition layer, third one is the analytics or the visualization, then the fourth one is the cloud layer or the application layer. So this is the layered architecture for the IoT applications or the IoT technology. So from bottom to top, it is the working is always from bottom to top. The working is always from bottom to top, that is starts with the sensing layer, then network layer, data processing layer, and the application layer. So the sensing layer, you are going to find out all sort of the devices, that is your sensors, actuators, then various devices, all sort of devices will be present in this layer, that is called as the sensing layer. Then the network layer. So in the network layer, we are going to have the technologies for the communication. What are the protocols, what type of network we are going to use for communicating the sensed information to the user. So that will be taken care by the network layer. Then the data processing unit. So this data processing unit will take care of the translation process. That means whatever the data is sensed from the environment, it may be in some different format, but when it is going to the machine, so the machine may require in some different format, machine required format. So all sort of translation activity will be taken care in this unit, that is the data processing layer. Then the application layer. So in the application layer, you are going to have a application which is going to provide all sort of information about a particular domain. So this is all the architecture. Then the benefits of IoT. So there are a lot of benefits you are going to get out of this IoT technology: data collection and analysis, efficiency and automation, improved connectivity, enhanced customer experience, cost saving, predictive maintenance, remote monitoring and control, energy efficiency, supply chain optimization, safety and security, smart cities and urban planning. So these are some of the applications. Apart from this, you may have a lot of benefits out of the IoT technology. Then, so few applications of the agriculture, few applications of the IoT technology. So whatever the domain you name, whatever the sector you name, everywhere you will find the application of IoT. So some of the domains are listed, or the areas are listed. One is agriculture, medical health, building and home automation, manufacturing, environmental monitoring, infrastructure management, energy management, transportation, better quality of life for elderly. So these are some of the applications. Apart from that, you may have more applications, which is where you will find the IoT. So one is the agriculture. So nowadays you might be hearing a word that is called as your precision agriculture or smart agriculture. So that is a hot topic nowadays. So smart agriculture means you are making the agriculture system smart by providing the connectivity of various components of the agriculture to the farmer at a single point. So that is called as your smart agriculture. And how this smart agriculture is possible? So that can be visualized through this. So this smart agriculture nowadays is called as your agri-tech. So you might be hearing this term, that is agri-tech. So some of the companies, they are coming and providing the solution for the agri-tech. So this is one of the example, that is the livestock monitoring. Livestock means the dairy business. Dairy business, they are moving towards the IoT to track the animals or to track the cattle. So they are using the IoT technology. And you might be seeing the cows and buffaloes, they are tagged with the RFID. You might be seeing the yellow color tags that will be tagged with their collar or in the ears. So that is used for tracking the cattle. That is used for tracking the cattle. So that tag contains a RFID, which is going to identify, or it is going to track the cattle where the location is. Clear? So that is one of the monitoring system that can be applied for the dairy farming. Then location, the farmer can locate the location of the cattle. Similarly, the health monitoring and what is the weight of the cattle, all these things can be monitored by using this IoT system through the tag. Then the next application is the soil monitoring. So in agriculture, soil is the important factor. So when the farmer is going to sow the crop, so first he need to check what is the soil ingredients, or what is the fertilizer levels. All these things are to be checked manually earlier. But nowadays, with the development of this IoT technology, so it can be sensed within a few minutes. What is the level, water level, what is the temperature level, what is the fertilization level. All these things will be taken care by using this IoT technology. And after getting the appropriate information, the farmer will be communicated, and he will be communicated in such a manner that he is going to get better crop yield. Clear? Then crop monitoring. So this is one more application. So by using this crop monitoring, so the farmer can identify what is the crop yield he is going to get. So for that, drones are being used. So by using the drone images, the farmer can identify and analyze what will be the final crop yield for a particular season. Then smart irrigation. So by identifying the red zones, so by using the drones, the images of the field will be taken, agriculture field will be taken, and from that image the red zones will be analyzed by using some algorithm. So after analyzing the red zones, the water or the irrigation system will be developed for the red zones, because it is unnecessary to provide the water to every part of the land. So where the red zones are available, you can provide the water to that positions only, so that the crop yield can be done in a better manner. So for that, a complete system was required. So here you are going to use a lot of sensors, actuators, and a lot of analytics has to be taken care. So the microcontroller boards will do the analytics and they will provide the proper information. Then pest and disease management. So this is the most important, the crucial factor the farmers are going to face. That is the pest control. So for this purpose, so along with this drone, so drones are being used for spraying the pesticides in the agriculture field. So apart from this, the image computer vision is used nowadays along with IoT, so that after taking the image of the agriculture field, so the algorithm will find out in which area the pesticides, pests are available, in which area of the agriculture field pests are available. So the drone is going to throw the pesticides in that particular area only. So that is IoT technology plus computer vision. So this is a combination. So by using this, so this farmers are going to get benefit out of this better crop yield. So one more example. So some of the students in KL University, they have built a drone with a 5-liter capacity of the pesticide. 5-liter capacity of the pesticide. So that drone will lift and it will spray 5 liters of the pesticides, and they have donated to the farmers. In Vijayawada KL University, they have developed this drone and they have donated to the farmers. It's a good one, good project. I have gone through that project once. Then pest and disease management. So this is one of the most important factor. So the pest may not be visible. The pest may not be visible in some cases. So in that case, the image analytics are being used. So these are the infrared images or the thermal images of the crop. And from the thermal image of the crop, it has been analyzed which one is healthy crop and which one is the affected crop. So after identifying which crop is affected with the pest, the pesticide can be sprayed over there. Clear? So where the pests are not visible, in that case this technology is going to work out. So here we are using the image processing technique along with IoT. So here the images what are shown, so those are the thermal images. The thermal images are going to show the heat portion of the particular object. So by going through that heat portion, we can identify whether the crop is good or whether it is affected with the pest. Then the healthcare. So in healthcare, lot of devices are being used. So the lot of sensors are being used to monitor the health condition of the individual. So these are some of the health devices, that is the digital stethoscope, thermometer, blood pressure, blood glucose, pulse oximeter, ECG. Before COVID, these were not available easily in the market. But after COVID, everything is available for everyone. Then this might be known to all of you. You people are using the digital watches, which is inbuilt with a lot of sensors, which is going to provide a lot of information about the individual health. That is how much steps you have walked today, what is the blood pressure, what is the pulse rate, all sort of information you are going to get from your smart watches. So that is your wearable devices. Apart from the smart watches, some other devices are suggested by the physicians. So when some person is unable to work, some sensors are provided by the physician. So they will track those sensors. They will track the movement of the particular individual from remotely, so that they can analyze and they can prescribe accordingly. Clear? And one more example is your pacemaker. Anybody heard pacemaker? Pacemaker. Yeah, supporting system for heart. Clear? So that pacemaker can be tracked anywhere in the world. If somebody has planted pacemaker at this place, so any person who is having the authorized user ID and password, they can track the functionality of the pacemaker sitting at USA also. So such type of devices are being used in the healthcare nowadays. Then prosthetic legs. So nowadays the smart prosthetic legs are being used for the persons who are physically challenged. Clear? So earlier the prosthetic legs were static, but nowadays the prosthetic legs or the prosthetic arms, they are very much smart. They will act according to how the human brain is thinking. Clear? So now these prosthetic legs are named as bionic legs and bionic arms. Bionic legs and bionic arms. Bionic means the signals that are generated from the brain, because the actual human movement, whether it is a hand movement or the leg movement, so that will be generated from the brain. So the brain signals will be captured through some device, and that device is going to provide the movement for the arms, that is your prosthetic arms or the prosthetic legs. So those are called as the bionic arms. So nowadays these bionic arms are being used by the athletes. You might have seen the athletes, they are using these bionic arms and legs. Then home automation. Sorry. So in home automation, you will find the various sensors that is going to provide a sustainable environment for your home. By taking all the surrounding parameters, it is going to provide the suggestions and it is going to provide the alerts for a safe home. So that is your smart home. So that is is the smart lighting. So by using this, you can control the lights. Nowadays, the lights are being digitized. So whatever the lights you are using at home, those are LED. LED means it's a digital component you can control through any device. Digital information can be controlled. Clear? So by using this smart light, you can control the lights. Then smart appliances. So whatever the appliances you are using, electronic appliances, whether it is a fridge, washing machine, or your any sort of, that is your what called microwave, all sort of appliances. So they are nowadays smart. So they can be connected to your mobile by using some app, and you can use those appliances remotely. So that is your smart appliances. Intrusion detection, that is your security system for your home. So by using the camera or providing some smart locks, you can restrict the entry of the intruders. Then the gas or smoke detectors. So these detectors are helpful if any mishappening is done inside the home. That means any sudden fire or anything is happened, or any gas leakage, LPG gas leakage is happened. So you will get the information, and accordingly your system will work. If your system is inbuilt with some action, so it may be possible that your doors will be opened automatically to exhaust the gas, or the windows will open, or the exhaust fans will be turned open. So if the provision is made. Clear? Then environmental monitoring. Environmental monitoring, so the key aspects are water monitoring, air monitoring, and waste management. So nowadays, this third one is the most problematic thing, that is the waste management. So to perform this, so a lot of activities taken care by the local governments. So air quality monitoring, so some devices are being used to monitor the air quality, what are the different gases available in the surrounding air. So based on that, if after getting the information, so proper action can be taken. So that is air quality monitoring. Then water quality. So this water quality, to monitor the water quality, so some water sensors that are kept in the water bodies, that is like your ponds or the rivers or in the wells. So these sensors will be they will be placed in the water bodies, and from there they will get all the information like pH value, oxygen, then pollutants, whatever is available inside that water, all information will be gathered, and based on that some remedial action will be taken to make this water safe and for use. Then waste management, so this is what called as the smart waste management. So here the dustbins that are kept in various places of a particular area, so those dustbins are provided with a RFID tag. So whenever the dustbin gets filled, so it is going to create an alarm, so that signals will be captured by local network. So some network will be captured whenever this dustbin is going to fill out. So whenever this alarm is generated, it will be provide the signal to the central system. The central system will instruct the local garbage collector trucks to collect the garbage. So this is one of the smart waste management system that is followed in the smart cities. Clear? And this is one of the application, that is your automobile. So whenever you are speaking about the automobile, so nowadays your automobile, car, or whatever it may be, it is completely inbuilt with the sensors. Clear? So one example here I like to quote. So I am traveling from Bangalore to Hyderabad 1 year back. So in the midnight the bus was stuck. I am traveling with a Volvo, it was stuck. Then I asked the driver what was happened. He told that, sir, some technical problem was occurred, so we are rectifying it. So after that we'll start. They have started again, but it was not the speed of, after starting, the speed of the bus was not reached up to 100 any time. So that's why we have got delayed by 2 hours. Because the technical problem, what the driver was told to me, that sir, the speed sensor was corrupted. The speed sensor is going to work based on the pressure of the accelerator. Whatever the pressure the driver is going to apply on the pedal, accelerator pedal, according to that pressure the engine will rotate and it will go in a speed manner. So what he told, that sensor which is kept at the pedal, that sensor and the engine sensor which are linked, so those two sensors are damaged. So that's why it went into manual mode. The running was went into manual mode. So in manual mode, the Volvo buses will not go beyond 60 speed. So this is how the automation is being carried out in the automobile industry. And one more example I have quoted, that after certain days or 1 or 2 years, in India also, you are not going to drive a vehicle if you are drunk. The vehicle will not start at all. So it is already being done in the abroad. Some countries they are already done, but India also, the transport ministry is looking into that. So these are, lot of sensors are available inside the vehicle, whatever you are using right now. And this is the transportation application of IoT in transportation. So public transport, fleet management, utilization of asset, management of inventories, and geofencing. So lot of applications are there in the transport also. So public transportation, then fleet management. Fleet management means the cargo transports, then utilization of assets. So all sort of things you are going to find the application of IoT. Then one of the thing is the smart traffic. Smart traffic management. So smart traffic means nowadays the big cities, they are facing a problem with the traffic management. So by providing this smart traffic management, the users who are using that complete path for traveling, so they will get the information about the traffic in advance so that they can choose the alternate route, or they will be provided with some alternate options. So that is your smart management. Connected vehicle. Connected vehicle means, so there may be some problem during the travel if the weather is foggy. That means in north side this problem occurs frequently. In north part of the India, this problem occurs frequently. That is in the winter season. The visibility is very less. So if you are driving at a speed of 100, it may be possible that you may got an accident in the morning hours, in early hours. So to overcome that problem, so the IoT devices can be used, which is going to provide the information about the surrounding vehicles. That the vehicles are surrounded with you, so you please go with this speed so that you are going to avoid the accidents. So that is called as your connected vehicles. So I have worked on this topic, that is connected vehicles, in 2019, and we have patented one concept, and that patent was granted recently in the last month by Indian Patent Office. That is the connected vehicles. That is to provide a safe environment for driver from one vehicle to another vehicle. So we have worked and we have used lot of sensors, and we have built a prototype, and we have submitted for a patenting in 2019. So just now last month we got awarded with that patent. So this is all about the connected vehicles. Then public transportation. In public transportation also it is useful. Then the last one is the smart city. So if you combine all the aspects, whatever I have discussed, all the applications, application of IoT in agriculture, water management, then air quality management, if you combine all the aspects, then you are going to have a concept that is called as the smart city. Clear? But till now there is no smart city which is fully functional in India. The work is going on, but still it is not fully functional. So this is one more snapshot for the smart city, which is going to take care of all the aspects of the sustainable environment. Then these are the various challenges. Of course, the technology will have lot of challenges. So the most biggest challenge for the IoT technology is the security nowadays. Because whatever the devices we are using, so those devices are interconnected, but we don't know whether this interconnection is safe or not, whether your data is being taken by some other people for misuse, so that we don't know. So the most most difficult challenge is the security part in the IoT technologies. Clear? So this is all about my presentation. So I need to discuss some more things, but I think it is about to start. It is about for the next session to start. So thank you all. Thank you for the patience sharing. Thank you.
Thank you, sir, for sharing your knowledge. We appreciate all the valuable insights you have provided.
I would like to request Sunil Hebale sir to present the memento to our today's resource person, Dr. Rajkumar Patra. Thank you, sir. Now I would request everyone to follow for a small break for 10 minutes. We shall be back by 12:15 for the second session. I would request everyone to gather to the auditorium. Shortly, second session will be beginning. Everyone, please gather quickly. I would request everyone to settle down.
Welcome back. The second session to be held is on the topic Communication Protocols and Interconnections by Dr. Bhagyashree R. Hanji, Dayananda Sagara Academy of Technology and Management, Bengaluru. I would request Shilpa to introduce our resource person to the gathering.
Good afternoon to everyone. It's my pleasure to introduce our resource person, Dr. Bhagyashree R. Hanji. Ma'am works as a professor at Dayananda Sagara Academy of Technology and Management in Bangalore, specifically in Computer Science and Engineering Department. Her academic career spans 2 decades. Ma'am has graduated with a bachelor's degree in Computer Science and Engineering from Karnataka University, Dharwad, a master's degree in Computer Network Engineering from Vishveshwaraya Technological University, Belagavi, a doctorate in computer science from the same university. At conferences and journals, both domestically and internationally, ma'am has presented research findings, patents, articles, book chapters, and books. Ma'am has also served on technical program committees, chaired sessions, reviewed papers, and editor-in-chief for multiple conferences and journals. Moreover, ma'am has coordinated national conferences and national level project competitions. Additionally, ma'am has served as resource person for FDP and Board of Studies and Board of Examination member. With this brief introduction, I present Dr. Bhagyashree R. Hanji. Thank you.
Thank you, Shilpa. Now I would like to request Pramila ma'am to welcome Dr. Bhagyashree R. Hanji. Thank you, ma'am.
Communication protocols are sets of rules that govern the exchange of information between devices or systems. They ensure seamless and standardized data transmission, defining aspects like data format, error detection, and synchronization. Today, to enlighten us about communication protocols and interconnections, we would like to invite Dr. Bhagyashree R. Hanji from the Anand Sagar Academy of Technology and Management, Bengaluru.
First job was also from KLE in Chikkodi itself. So I am 20 years back, coming back to Chikkodi and giving this session. That's a very proud moment to me. With 0 months of experience, I started my career in KLE, BK College, Chikkodi Polytechnic. I had served there for an year and so 2001, 2, and again back here for this session. So that is a very proud moment to me, just to connect to KLE. And coming to this session of today, where we are going to discuss about the communication protocols and interconnections for IoT. This is not working. Yeah, thank you, sir. When it comes to communication scenario, IoT, do you really think it is a new terminology which has existence 1 year or 2 year back, or it is being used decades of year back? Anybody? Let us be interactive, because let it be an interactive session. Does it come into existence very near nowadays, or have we been using it, this technology, day in and day out? So we use it, even if you see now in everybody's pocket, you have a smartphone, which itself is a very big example for IoT. Though we use only the screen of that, but behind technology, we have lot many of sensors which have been incorporated into that. And the very big business which is involved in IoT is your Intel, Microchip, we have Particle, Atmel, and all these companies are involved in that. When it comes to IoT, it is not only the device. I am given the topic of protocol. If I say a system, your laptop or your own smartphone, if it is isolated, it's just one object. But only when it is connected, it can send or receive the data, then comes the existence of technology. So I require an end device. I require a medium for where your data needs to be sent and received, that is transmission media. And more importantly, the protocol is very much should be in place for any two devices to communicate. For example, now if I start speaking in French or Spanish, so it could be very difficult for you to understand. So for me, the protocol here is what? I need to speak in a common language which is understandable by you and me. So similarly, in this case of IoT, your communication protocol plays a very important role. And since I have heterogeneous devices which are connected, which are not similar, and which don't provide a similar kind of data, in that case, that is a reason my communication protocol plays a very important role when you speak of IoT. Now, just to start with a warm up, when I say internet of connection, it is not just connecting every device to other device and then you send and receive messages, where a lot of electronic components are involved in that, a lot of softwares are involved in that, and then you are going to connect them or embed them, and then they exchange data. The very big or very nice example is your own mobile phone, which has, I think, all these applications would have been there in your mobile. GPS tracking, your GPS Google Map. Do you have them or not in your mobile phone? Yeah? Adaptive brightness, as you travel, your screen changes. And similarly, your voice detection, and then your phone, your brightness, everything. All these are already present and we are using IoT. Why do you require? Is it really required? Because nowadays everything is connected. Everything is connected to each other. Do you really require IoT? Anybody? Anybody from student side? Do you really? Because if I am not wrong, you also study Internet of Things in your 8th semester and you also do your projects in IoT. Is it that very important? IoT? Yes or no? One yes or no? Is it okay? You say yes because you have write an SCE exam and you also write an internal exam for that. Okay, fine. It is very much important for our day-to-day life because we are expanding our interdependence of, when I say we, it is we humans. We try to interact with each other, we contribute by sharing the data, and we collaborate. Collaborate with whom? Collaborate with a non-living thing. So we as a human, we interact, collaborate and contribute with things. And those are two pictures which I've just taken from Google, where most of the times we use for the hospital management and the transportation system. And we require IoT because we need to utilize our resources efficiently, the prime reason. And our efforts, human efforts, to be reduced, save my time, and then have some security improved concept, and more importantly, how you are going to collaborate AI with IoT. So these are few reasons why IoT is so booming technology now. Now, when you see the statistics, it is surprising that why do any organization use IoT? So this is, I have taken from IoT Analytics website, which says for 24% is used only for safety, IoT. Whereas 35% they make use just to make money out of that, generate revenue. And 54% to save the money. So your safety is the least involvement here. So 24% for safety, you have 35 just to make money and 54% to save money. This is the statistics why any organization, when I say organization, it may be an industry or any other academic who implement IoT. Coming to the ecosystem of IoT, it again follows the 5 layers, or in sometimes it is taken as 3-layer structure also. Coming from the bottommost layer where most of our sensors are involved, which is called as the perception layer, where you gather all the data, sensor data when you speak about maybe the soil sensor, temperature sensor, whatever sensor you consider. So you consider the sensors at the bottommost layer and it is called as the perception layer. And after that, when I am communicating, I require the transport layer also, which is a second layer and which provides communication between different types of networks. So I say here Bluetooth, it may be your RFID or maybe your local area network. This data after transmitting, I need to process it and store it. So that could be taken care by the processing layer, followed by which we use most of this, they come under application layer. And then entire thing to clubbed together makes an IoT system which includes applications, businesses and the profit models. They all come and sit in the business layer. So this is the most common used 5-layer IoT ecosystem. And these are few taxonomies which we will be using day in and day out, where we start with the perception, that is the bottommost layer, and then that is a processing layer where you process it and filter the data, and then communication between the two entities, followed by the middleware. Middleware is just going to hide certain information. It's an abstract layer, so I don't reveal all the details. And followed by the topmost layer, which is your application layer. And application layer is directly connected to the end user, that is me and you. Now, IoT, when I say, is it only limited to your mobile phones or is it only limited to your transportation system? No, each and everything is connected. So, starting from healthcare to industry, to city, environment, transportation, agriculture. Maybe I would have missed 1 or 2 in this case also. Everything is connected. And it's more dangerous too, because everybody is tracking me and you. When I am connected to the internet, we are being tracked. Okay. The connected objects, they fall into 4 categories when I say. It is the connecting object to another connecting object, so one device to another, or it may be connecting to a particular service, or you may be connected to a user or user to the service, so back to back. So these are the different ways where you can connect the object. When I say I am going to exchange the data, to exchange the data I require what? Transmission media. And networking and IoT very closely related. So I have my IoT devices which could be controlled over the control devices, and in between those two I require a wired or a wireless connection, which is very important. Is the transmission media or networking important, or is it okay if it is not existing? Anybody? Is it okay if you are networking the whatever I have put up, cloud, Bluetooth, cellular, low power wireless area network, even if it doesn't exist, does your IoT exist there? No. So it is very important, the middle part which connects your IoT devices with the monitoring or control devices. Now the communication protocol, when I say it plays a very major role, or I call it as a backbone of IoT system. And when I say backbone, it is very important which connects your end user or your IoT devices to the applications. Now they allow the devices to exchange the information. Now, do I have protocols only at a particular layer, or will I have protocols at every layer? Where I have shown you 5 layers. So we will have protocols at every layer. Maybe it is a link layer or network layer or transport layer, and also till the application layer. So I will be having protocols at each layer. And each protocol, when I am saying, they are going to exchange the data in a particular format. Okay, so that would be taken care at the data encoding, addressing, and data exchange format. Other than this, my protocols also take care of what? Flow control as well as error control, or it is retransmission of any lost packet. Now we need to understand this slide. Where do I have only protocols with IoT? No. Protocols are there when I say computer networks or your data communication when you're studying, we do have protocols. Now what is that difference between a traditional protocol or protocol which is used for general purpose and the protocol which is exclusively used for IoT? When I say IoT, you say you have a small devices, very small devices which you will be using. Will they be having huge power? Will they have very low power? And then why do you use IoT mostly? Where humans cannot reach, that places you install. Now could you go and charge them every now and then as you do your mobile phone? No. So we have to take care of certain constraints when it comes to protocols for IoT. The very first is it should use minimal power, my IoT protocols. Second one, it should have less data for some same set of sample. And the overhead should be less. So header information is only one time overhead, whereas here when I say TCP, IP, UDP for connection oriented or connectionless, my header repeats for every segment. And it should be lightweight and it should have only less space. Maybe it is in RAM or ROM. So these are some 5 to 6 points which we need to take care when we are dealing with the protocols using IoT. Your IoT communication protocols, they are divided into 2 types. One is related to exclusively the network protocol and the second one is related to the data protocol. So under network protocol, we have an example which form, and this is the Z-Wave, your Bluetooth, HTTP and LoRaWAN. So these are the examples that come under network protocol. Similarly, when it comes to data protocol, I have MQTT. It is Constrained Application Protocol, COAP, and then Advanced MQP protocol and Extensible MPP protocol. We will be looking into these protocols. So in general, we have all these protocols which contribute to your IoT. When we say the devices are there, then I have the analysis is there, we have the network in place, I require some models. So in the communication model, I have 4 types of communication model which are used in IoT. The first one is the request response, then it is publish and subscribe, push and pull model, and exclusive pair model. So these are the 4 models which your IoT will fall into. The name itself indicates, when I say request response protocol, I have one user who would be requesting and one user who could be responding with the help of the resources. Can anybody give example which fall under this category, request response model? Request response model, when you as a user, when you're browsing, Does it fall under the category of request and response when you're using your regular internet? Yes or no? Okay. So request is always initiated by the client who sends the request to the server. The server will look up what you are asking for. It is going to process it, fetch the information using the resources, and it's going to reply back to the client. So that is your request and response model. Very simple model which is being used. The next model is your publish subscriber model. Again, it's a very popular model. Can anybody tell me very common example which follows this publish subscriber model? Buying the newspaper, okay sir? Any other example, most popularly which you use even day to day life, maybe even in this auditorium you would have been using it? YouTube. Your YouTube, when you subscribe, isn't it? Will you get all the notifications for anything that is put up there? Yeah. So YouTube is one popular example which uses publish subscriber model. I have a number of subscribers, and whenever I put up any data or when I publish any data, that could be taken care centrally through this broker. So I am going to publish, and the broker is going to take care of pushing up all the details to the customers or the consumers who have been subscribed to that. Now, if you see that diagram, I have topic 1 and topic 2. So I have some 2 consumers for topic 1 and maybe 1 or 2 consumers for topic 2. Anything when published with respect to topic 1 would be given only for consumer 1 and consumer 2. Yeah, consumer 3 is not going to get that. So this is again a popular model which is used by MQTT protocol, publish subscriber model. And the broker is nothing but the name is given as broker, but it acts as a server in between the publisher and the user. So broker is a name given, but the functionality is similar to the server. And the third category is the exclusive pair model. So here it is no n number of users. It is always 1:1. So I have one client and one server. The events happen and then the session is closed. So it says I am going to first, when I want to communicate with you, what I do is I need to request you. Hello, I want to speak to you. That's the request. After that, when you say yes, nod your head, then that is your response which I am going to get. Followed by that, whatever I want to communicate, those messages I'm going to send it to you. So that is message from the client to server. And then your response to my talk. So that could be the fourth topic, that is message from server to client. And once I am done with that, I'm going to close the session or close the request. It is very similar to your phone call when you do. When I say hello and you say at the other side hello, that is your first 2 messages. And then you talk whatever you want and then it's okay, bye. So that's the last part. So in this model, it is a little bit expensive because always only 2 entities are involved and all the resources could be kept reserved for the 2 entities. So that's one part of this exclusive pair model. Then coming to the push and pull model. So when it is push and pull model, again, when I'm downloading any data from the internet, yeah, would it be pulling the data or pushing the data? When you're downloading any data from the internet, pulling the data. When I am uploading any data, suppose you're filling a Google form and you want to upload your photo, that is what? Pushing the data. So in this case, when it comes to push and pull model, queues will be involved, where I say buffers are involved, temporary storages. So when I have any data to publish, so it could be saved in the queue and then from queue it is going to go for the particular consumer. And then the same thing happens for the second queue or maybe topic 1 and topic 2. And in this case, again, it is always the publisher who is going to push the data and it is always the consumer who is going to pull the data. It is always a one-way flow. I cannot have the reverse way. So queues are just a temporary management for the pushing and pulling of the data. Now this is a protocol stack, which gives entire details of all the protocols that have been used in IoT. The one which comes at link layer, you might be aware of that, the Ethernet, then WiMAX, Wi-Fi, and the cellular protocols with all those notations. Now coming to the network layer, we have IPv4, IPv6, and then 6 LOWPAN. IPv4, which we use. Do your cell phone have IP address? Your smartphones, do they have IP address? Yes or no? When they are connected, they will definitely have. Is it unique? Is it a unique address? Yeah. So IPv4, we know since addresses are depleting, we are going to go for IPv6 addresses, which is again 128 bits. We would have studied about that. So again, whenever it is, though I am dealing with IoT, I would still be using the basic protocols of IPv4 addresses or IPv6 or then low power WPN network layer protocols. Above that comes my TCP and UDP. When I say TCP, the transmission control protocol, it is always what? Connection oriented, or when you go for UDP, that is connectionless protocol. And then the major portions when it comes to IoT, I am going to deal with the hypertext transfer protocol, or you say HTTPS now, where S stands for secured. And then constraint application protocol, that is COAP, followed by WebSockets, and then you will be having MQTT, extensible MPP, and then advanced MQP. So these are the important protocols which are related to IoT. Coming to AMQP protocol, it is freely available. So this is an open standard protocol which is used to send the messages related to the middleware, and it enables the interoperability between the systems regardless of whether it is a message broker or any platform, and it also provides security. So it is involved with interoperability as well as security, and it supports even when the nodes or the systems aren't simultaneously available. Now simultaneously available means what? When you send an email, is it mandatory that the receiver should be available when you are sending? Not required. He may be offline also. Even the receiver, if he is offline, can you still send an email to him or her? An email. It's possible, isn't it? So even here in this case, the system aren't simultaneously available. It's okay. Whenever online you receive it. So this is supported by AMQP protocol, and it has its own set of frame types. One is to open the connection and then begin the connection. Then you attach a new link to that, transfer your required data, perform the flow control. Once it is done, you detach, then end the session, and finally close the session. So it is like open is related to close, begin is related to end, attach and detach, and in between you are going to transfer. These are the different steps or stages that are involved in AMQP. What are the different types of guarantees that are provided by AMQP? When I say TCP, you say it is reliable, isn't it? We make use of the term the transmission control protocol is reliable. Why I make use of that term? Because it is connection oriented. Whatever I send, you will definitely receive it. In this case, it will provide three kinds of guarantee. It is at most once, at least once, and exactly once. At most once means you may receive once or you may not receive. Whereas in the case of at least once, you will receive minimum one time and probably more than one time. That is duplicates. And exactly once is neither duplicate nor you're going to lose. It is exactly once I'm going to receive the data. So these are the three types of delivery guarantees. And the different features that are supported is the security, as we have seen, interoperability, and then you have routing. and then the queuing, and it also supports the open standard. The second protocol was MQTT. MQTT protocol. Now, is MQTT protocol related something to these images which I have taken from Google? Could you just relate MQTT protocol, which is an IoT protocol, and then you have these factories photos which I have put up. Any relation between those two? Was MQTT protocol only used for your cell phones or only used to your classrooms? No, it had a way back. The start was from, I think, 1996 or 7 there, where the photos which I've put is of oil and gas refineries, where different sensors have been deployed and where human intervention was very difficult. There started this MQTT protocol. It's a very old protocol which is being used. And during that time, the different sensors were installed at different plants where it could be used to measure the temperature or measure the humidity or the gas combination and all those things. And then the data was fetched and further analyzed using the SCADA. So that's the history of MQTT protocol. It was first developed in 1999, and MQTT stands for Message Queuing Telemetry Transport. Though it has a queue in between, but it is usually processed with any messages saved in the queue, and it follows the publish and subscriber architecture, and it also enables machine to machine communication. And it is a very simple protocol which involves the communication between multiple devices. And very importantly, it works for low bandwidth situation also. It need not be always a higher bandwidth since you are doing with IoT. So it will be available or working with low bandwidth. And different components, because when you are working with a protocol, these components play an important role. I have three kinds of component. One is the publisher, subscriber, and the broker. So broker is the one intermediate who connects what? The publisher to the subscriber. Now subscriber is nothing but I and you who are interested in some application. And the publisher is the one who is going to give you the information. When it comes to IoT scenario, your sensors will fall in which category? Publisher. And when I'm analyzing, I fall into which category? Subscriber. And in between, the data needs to be processed and it should be given. So that comes under the broker category. Very simple understanding. And different methods which you require. One is the connect. I need to get connected first. And then after that, I subscribe if I'm interested. If you don't want, you just unsubscribe. So that subscribe is the second method and unsubscribe is the third method. And then when I'm subscribed, if you want, you can publish any data. And then finally, you can come out, that is your disconnect. So 5 important methods. One is connect and related to disconnect, the matching methods. Similarly, subscribe and unsubscribe. And the third one is the publish. So these are the important functions. When I say communication, it uses again publish subscriber architecture, and it is event driven. Event driven is when anything happens, when it is sensing anything, then only it is going to send the data. That is its meaning. And the central communication point here is the broker, or you call it as MQTT broker, which is the whole and sole responsibility to dispatch all the messages between whom? Publisher and the subscriber. So the entire responsibility lies with the MQTT broker. And how is that topic represented technically? It is represented using the forward slash. That's the example which I have taken because we could relate it more better. When I say smart home, you come out, you on the AC only when the temperature, when you feel it too hot. So it is house slash living room slash temperature. That is how it is represented. Means in your house, in your living room, and there what is the temperature. Similarly, on the second line, I am relating it to my kitchen. So house and then kitchen and then I have the temperature. Now instead of writing every time, I can make use of this plus symbol. If you see in this third case, the plus symbol is used for single level hierarchy. One level, I can either house will be there, temperature will be there. In between, I may have my living room, my kitchen, my puja room, whatever. So that is one wildcard entry I can have with the plus symbol. Similarly, I can also have multi-level entries or multi-level hierarchy. In this case, it could be represented by hash symbol. Hash. So what I have written there, house slash hash. So hash may take living room and temperature, hash may take something else. So in general, when I say plus, it supports only single level hierarchy. And when I make use of hash, it follows multiple hierarchy. Now, it's the same. Clients, do the clients require to know each other in this publish subscriber method or in this MQTT method? Now, I am the I am a subscriber for a YouTube for some particular channel XYZ, and even you are the subscriber. Is it mandatory that I should know you and you should know me? No, not mandatory. So that is what is said. Clients don't have to know each other. The architecture of MQTT, it is very much scalable. Is it limited that any channel will have only 100 subscribers? No. So it supports scalability. That is highly scalable solution without dependency between the user. That is one of the highlight of this publish subscriber model. Each client, he should receive the message, whatever is post up to date, and I need not have any communication with the other client, and I can have any number of nodes which are connected. So it is highly scalable model. These are the plus points of this MQTT. And the different applications is your Facebook Messenger, which is your online chat application, also uses MQTT. Though we use it, we don't know the protocol that is used behind that. Online chatting, I think students than us. Have you used online chatting? Yes or no? Okay. Now you remember the protocol that falls behind that is in MQTT, and then Amazon Web Services, which we use, and then Microsoft Azure, Adafruit. In my first slide, there was a fruit picture. Okay, even that uses of MQTT and everything IoT platform. These are few popular applications where this protocol is being used. Coming to when I've said so much, just a small slide which tells how this MQTT broker or server uses. Now the two messages which MQTT uses is one is to publish and the other one is to subscribe. So those are the two messages which are being used. And suppose I say at some industry, at some location A1. When I say industry, it is a huge area. At particular area A1, I want to measure the temperature. Now, when I want to know the temperature, now temperature I should know where I am sitting in my office. So, should the temperature be read from area A1 and it should reach me? When it should reach me, it should be published by someone. Yes or no? When you need to receive the notification, will you receive notification just like that? Or only if someone has uploaded any data, you will receive a notification? Yes or no? So there should be, the data should be published. And that should be taken care by whom? Will it receive you directly? No, it should be through the broker. So when that sensor, that client at location A1 says that the temperature currently is 32 degrees and that is being published. So then that could be stored here in a shell where it is called as a topic, where I say there I have A1, that is the area, and the temperature is 32 degree centigrade. That is noted where? That is noted at the broker or the server. And then after that, only receiving the data at the server is of no use. It should reach the subscribers. Suppose if I have a client there, which is shown with laptop, the data should be sent to that person also. So the communication, the data is either the topic is shell /A1/temperature. The technical term used here is topic. Topic is a term used for any message that you want to send, or it is just a string. Now what is its content? The shell and which area A1 and what it is. That is shell /A1/temperature. Now that is the first string. Along with that, there is an attachment that is called as message or payload. What actually you want to send. Now I am sending what? 32 degrees centigrade. So that is also being attached in my message. So this is one client who is going to receive. Now suppose I have one more person who is using that application in your cell phone. Now the same data needs to flow to that person also, the published data. And after that, say suppose I have one more component which measures the flow of fluid, and say the flow of fluid is 25 meter cube per second. So that is a flow of water or flow of chemicals, whatever. So in that case, I need to measure the flow also. So what should be done now? That component also should publish the data. And where it should go and sit down? It should be processed by the server. So there, earlier it was A1 temperature 32 degree, and now I have A2 flow 25 degree. And then after that, what should it be? Suppose we assume both of those two clients are also subscribed to this. Now what should happen? The flow information should go to those two also again. So that is how it should go. So this is a very simple animated clip just to show how that MQTT protocol actually works. I hope it has made some sense for you. And then coming to the security part, because that's very important, your TCP IP 1883 port is completely reserved by IANA only exclusively for MQTT protocol. The port number 1883. And similarly, port number 8883 is also registered for using MQTT over secured layer, that is SSL protocol. So these two port numbers are fixed, and that is the reason that it provides the security. And above that, you can also have a firewall which sits in between the publisher and the broker, and that provides your better security for that. So this is how the MQTT protocol works. Hope I am fine with the audience. Okay. Yeah. Moving back to the next protocol, that is Constrained Application Protocol, or it is written as COAP. And it is defined in RFC 7252. Now RFC is a request for comment where the entire document of any kind of protocol could be defined. So you have different numbers for each protocol. So COAP is documented in 7252 and it is openly available in Word and PDF. You can download it. And this COAP is also known as a web transfer protocol. It is used for IoT and it is used for M2M communication, and it is based on request and response model. So your MQTT was publish and subscribe, whereas here this uses request and response model. And here the communication is asynchronous. Asynchronous, when I say, need not be guaranteed communication. When I say no guaranteed communication, obviously my transport layer protocol could be what? UDP. So it is asynchronous, and you make use of the user datagram protocol at the transport layer. This is again few things which was found out by IETF, that is your Internet Engineering Task Force, and it was launched in the year 2013. And COAP, it depends on user datagram protocol, and again it uses machine to machine protocol, and it uses low bandwidth, and it is also using low availability and also low energy. So it is satisfying most of the criteria for IoT protocols. And why you make use of protocol and what it is not. It means what? It is not a replacement for HTTP. So HTTP has its own place. Okay, your hypertext transfer protocol. COAP, it is not a replacement for HTTP, and HTTP, it's some compression mechanism, or it is restricted for automation use. Whereas your COAP, it is exclusively designed for machine to machine and on the IoT platform, and it is or it supports proxy to and from HTTP. So these are two important terminologies, and it is suitable for constrained devices in the network. Some features which we are all aware of all these things. So it is again an open standard, and it is also called as web transfer protocol, where you write it as COAPs colon and slash, and it uses the ports 5683 and 5684. In the previous case it was 1883, and it provides security, and it uses UDP and also SMS, and it supports asynchronous, and it uses get, put and post method, which we usually use with HTTP protocol, and it supports a very small compact header of 4 bytes, whereas UDP goes with 8 bytes, so it is still smaller than that. And the different terminologies which are involved in this, one is the entity, the second one is when I am sending the message, the originator of the message is the sender, the receiver of the messenger, or if you are the receiver, then it is a destination, and then the client who is requesting the data, and the server who is going to respond to your data. Some bookish terminologies which are used when you are using this COAP protocol. And different types of messages that it supports. First one is the confirmable message, non-confirmable, acknowledgement and reset. So confirmable message is one, see now if I ask you any question, I will wait till you respond. Okay, whether I want or I don't want, I wait till I receive any response for you. That is a confirmation message. So it requires an acknowledgement, mandatory. When I say non-confirmable, it does not require. I just go on telling, it's left to you whether you take it or not take it. So that is the second category. Acknowledgement, this third message is related to the first message. Acknowledgement is that it is the response. When I am putting any query, the response is the acknowledgement, and this acknowledgement is for the confirmable message. So confirmable message is the request, acknowledgement is the response to the confirmable message. And then reset, it is that I reset or restart, and whenever you are not able to process anything, so you make use of this reset message. This is how the architecture, COAP architecture looks, where there would be a communication between machine to machine or the client to client there within a defined environment. And the term used here is the constrained environment. But when I am connected to the internet, I also have a client server communication with HTTP and the REST environment in that. And then you will also have when there could be a communication between the two nodes in the constrained environment and in the internet, you will have in between a proxy which could communicate. The proxy could communicate to the constrained environment using COAP, whereas to the internet side it could make use of HTTP protocol. And similarly, I could also have COAP with the client and the server. So this is how the COAP protocol works. In general, when you want to show the messages that are exchanged between the client and server, the first one is the configure or the message, first message which is going to be sent, and along with that it is sending a request, that is get the temperature. So that is the first message, and it's a confirmable message. When I say confirmable, it should have a response. So for this I have acknowledgement as a response, which will send me, since I am asking the temperature through the get command, it is going to send me 22.5 degrees centigrade. That is a response to that message. So this slide is an example for confirm and acknowledge message. And if you see the 5-layer protocol stack, at the 5th layer, that is your application layer, you are going to make use of the COAP protocol, which works in terms of request and response. Along with this, the message. Message is the content. And then the below protocol, it is UDP, and below that you make use of IPv6, and then it is going to support IEEE 802.15.4. So these are all the protocols which are used in line when I'm making use of COAP protocol. And the next protocol is AMQP, Advanced Message Queuing Protocol. And usually, again, this is an open standard protocol and which could be used for since the term advanced is used here, it is mainly used for transactions. So the third point, it says it is mainly used for transaction between the servers and the users, where you need little bit of security. And earlier message COAP used UDP. UDP, you always say it is unreliable, but here it's mandatory that it uses TCP. TCP, which is reliable, where you can rely on, and it is used for the transaction purposes. And every time the client acknowledges the messages. Acknowledge. Can you give any example where transaction messages are involved and you receive an acknowledgement for that? Anybody? Your bank, suppose now you deposit or withdraw anything, any transaction. Will you get an acknowledgement? Get or not? If you don't get, what you do? If you don't get, what you do? Contact whom? Bank. Okay, fine. So now, is that a reliable transmission? Is it the reliable transmission of the messages when whatever example you gave? Yes or no? We rely. That is why you make use of ATM, you make use of credit card, debit card, everything, because you rely on that. Similarly here, this protocol is reliable, which uses TCP and which uses confirmable messages. And then it follows publish subscriber model for communication. Will you be receiving all the messages that are updated from the bank for all the customers who are having account in that particular bank, or only few will get the messages? Anything, any updation, they would have put up a new scheme, they would have changed the rate of interest, anything, any kind of messages. All the customers will get, all the account holders will get a message, or only few will get the message? Only few? All the account holders of that particular bank will get that messages related to that account. Suppose you have an SB account. Will you get any message or not? Okay. If you have, say, a locker in that particular bank and you are locker charges have been changed, will that message be sent to all the locker holders? Okay. Then do you call that as publish subscriber model? Do you call that as a publish subscriber model there? Yes or no? Someone is going to publish the message and it is you who all as account holder who receive the message, isn't it? So these are some points of AMQP protocol. And then this is the format that could be followed. You have a frame body, which is your actual message, and then you have a header followed by the size, data type and formats, which you could get it from the details, isn't it? Let's not. And the different types of frame here is again open, and a matching for that is close, begin, and a matching for that is end, and then you have attach, detach, and then the flow of data, that is transfer, and then disposition. Now this is again the fundamental components that are used in your MQTT broker. I have a publisher and I have a consumer, and in between you have the routers which are going to route the data. You have the exchange as well as the queue, and the entire system that is in between, you call it as MQTT broker. This is another example where multiple publishers and multiple consumers are involved, because when I say routing, I will definitely have more than one consumer and more than one applications running there. Okay, so this is another example for AMQP topology. And then certain advantages. Okay, that's a spelling mistake. It can be extended easily. Typing mistake. So it supports 3 level of quality of service and it can be extended easily, and it has its own inbuilt security system, and it supports open source libraries. We are aware of all this Bluetooth and BLA, which supports what? A low range or a short range wireless technology, and it uses short wavelength and ultra high frequency. And it is mostly used. Bluetooth is mostly, for what purpose you use Bluetooth? Let me get an answer from you only. For what purpose you are going to use Bluetooth? Short communication, and it is most popularly, or the application is for audio streaming, and it is a low power, low range and low connectivity option. And then we have the cellular, and again which is widely available. We make use of the term 2G, 3G and 4G, 5G. So they all require again a higher bandwidth compared to Bluetooth, and the cellular, they are reliable. So it is high bandwidth and reliable communication. It is capable of sending high quantity or huge amount of data. And then you have DDS, that is the data distribution service, which is managed by OMG. So that is your object management group. Okay, and again it is a middleware protocol, which is more centered to data, and again it supports machine to machine communication, and it is highly reliable and it has high performance compared to the previous. Okay, and then this is again a most popular protocol, which you might have, we usually utter. So that is your LORA, that is a long range, and it is non-cellular. It doesn't support cellular structure, and it's a wireless technology, and it is usually we use it for long range communication. Bluetooth is for short range communication. And here when I say LORA or LORAWAN, it is the secure communication between the machine to machine. And the same thing we have, these are the different protocols, but the most popular one is your MQTT and COAP. And then we have Wi-Fi protocol, which is used in the home, that is a smart homes you use, or it can be used for commercial purposes, or it can also be used for IIoT, that is your industrial IoT. And it is, this Wi-Fi is particularly suited for one campus or one building or one LAN environment, that is short to medium range distances. Wi-Fi is your Wi-Fi, if you are awning here, would it be available on the main road of this campus? On the main road of this campus? No. So that's an example where you use it in a smaller environment or your LAN environment within a campus. And then it again has many standards, where when you get connected to IoT, lot many of limitations are also involved when you want to deploy that. Now when I am speaking of all these protocols, we have done it theoretically. Can we have any tool that could analyze all these protocols, little bit beyond your FDP content? Any tool which we have used, which will analyze, I am speaking of TCP, I am speaking of UDP, all this acknowledgement, all those messages. I say that you send a message, it uses all these protocols and all that. Can we have an open source tool which will tell you the analysis of all these protocols? You might have heard about Wireshark tool. It is, it's an open source tool which you can download in your system, and that could be used. Maybe if you would have heard about that, it is Wireshark. If you would have heard, that's fine else. So Wireshark, it's a tool, open source tool. It doesn't require, you use it, you install it, use it and then uninstall it. So when you are connected to an internet, and then will there be data transfer between the sender and the receiver when you connect it to the internet? Say I connect to the internet and I open Google. And then I type KLE Chikkodi. Am I sending any request to whom? To the Google server. Will the Google have only one server or will it have multiple server? Multiple server. So will you be knowing to which server you are getting connected to? No, isn't it? The only assumption is it uses the shortest path, whichever server is shortest near distance. But again, that is wrong. It is not always the shortest distance. So it has its own algorithm to get connected. Now, when I am requesting for KLE Chikkodi and it is responding back with so many all pages, so I click on the first one. So I am again clicking, and again when I click on your official website, am I again sending a request and then your web page will open, your college web page would open, isn't it? So I am always requesting and I am responding. In between this, are there any protocols which are coming into existence? Whatever we would have studied need not be IoT. You have HTTP, isn't it? HTTP or HTTP? Yes. And along with that, I am requesting and it is responding. Will there be an underlying protocol coming into existence? You might be using TCP, you might be using UDP, you might be using acknowledgement, ACK, all those things. When I say UDP, you say 8 bytes. In theory, we studied, and when I say TCP, it is 12 bytes, and then it has its own, we always study in theory, it will have the port number, source port number, destination port number, source address of 4 bytes, destination address of 4 bytes, and all those things in theory. But this is one of the very nice tool. Once I should be getting connected to the internet, and then let me work for 2 minutes also, not even more than that. And you have to start, you have a start button. Once you click on that, it will capture all the messages that have been sent and received from your system. All the messages. Messages will be so many that you will require lot much time to analyze that. So this is one I thought of telling Wireshark tool, which is open. Any kind of message or protocol could be analyzed from what time it is sending, what it is receiving, which port number it is using, what is the source address, to which server it is getting connected. All such information could be used. Now, when I am saying it is for a regular protocol, it can also be used for IoT. Since we have a topic communication protocols with IoT, I can use the same Wireshark tool. Now, what I should have for TCP, UDP and all those things, simply my laptop now which is being used, I can analyze all those. But when I have an Arduino board which is connected to my laptop, I have certain devices which are connected and I have programmed it and it is connected. So my laptop, would it be connected to, does it follow now an IoT environment when I have an Arduino board connected to my laptop, isn't it? So now when I again use the same Wireshark tool, then it is going to analyze all the communication protocols which are related to IoT environment. Earlier, when no board was connected, it was just an internet protocols that could be analyzed. So you can have just have a look at that protocol once you are free. So that's one of the very easy and manageable protocol. You can download the Excel file and then you can work on that. So you will have an download option where all the messages that are sent and received can be downloaded. So you can explore that protocol. And then we have the XMPP, which is again the extended, and it was found out in the early 2000s. So it was the later part after 1992, which was MQPP. And it supports this XMPP extensible, which supports real-time exchange of the structured protocol. And again, this is all an open source protocol where we need not pay, and it will support all the standard formats. And then we have heard about that Zigbee, and usually we use it. It is a longer range of Bluetooth, BLE, and it supports lower data rate, and it's used in mesh protocol or mesh network structure it supports. And again, it was particularly used for home automation, the Zigbee protocol. And then we have Z-Wave. Again, it's a wireless mesh network communication protocol, and which is used for low power radio frequency technology. And it is again similar to your Bluetooth or Wi-Fi or Z-Wave and all those things. And again, as in the previous case Zigbee, Z-Wave is also used for home automation purpose. And is it required to choose a right IoT protocol? We have seen so many all protocols. Can I use any protocol for any kind of application, or should I have some analysis or theory behind that? Should we have some concept to think which protocol I need to use? Or just like that, now we have seen around 8 to 10 protocols. Can I use any protocol randomly? No, I need to analyze for my application what are the requirements and then select the protocol very carefully than just choosing any random protocol. So that your security requirements, where you are going to install it, how much time it should be working, all those things needs to be taken care. And again, when I want to have the performance analysis of these three important protocols, other protocols are there, but very important protocols are MQTT, COAP and HTTP. Now these three protocols we had analyzed at our end using the Wireshark tool itself, where Arduino board was connected, and then we have analyzed these three protocols. Okay, I could not get it here because this one, but I could share with the Golgi sir, and then you can go ahead with that if required. And coming to the more technical content about that, the MQTT header at the application layer, we'll just move on fastly for that because we could get this contents also later. So it will support the lightweight, and it supports publish subscriber, and at the application that is the transport layer security TLS layer, which is an extra layer added between the transport layer and application layer, which supports the exchange of messages between the client and server. So the transport layer security, and it is mainly used for security or data confidentiality purpose. That's an or integrity. And then you have the TCP transport layer, which makes use of either TCP or UDP. And then below that I have the network layer, which supports your IP routing or your MQTT, followed by the data link layer, where you make use of the Ethernet or 802 series of protocol. And then we have the physical layer, which is also called as Wi-Fi or Ethernet layer. And then these are the matrices which I have used when we were integrating that. Though the size may vary, when I say a frame size which goes to 80 bytes, 80 bytes in turn goes from the lowest layer, that is the Ethernet layer, whose size is 14 bytes, followed by the IP layer of 20 bytes, and then TCP, and then MQTT. Like this, it goes totally to 80 bytes. That is one frame size when you are deploying or when you are analyzing using the Wireshark tool. And then further, the application header, that is MQTT itself, the 14 bytes, how it is being segregated, the different flags that have been used, and all those things. So these are few. And similarly, when I want to publish or when I want to request anything, the size of the request header could go to 136 bytes. And again, any request when I'm going the lower layer from Ethernet to IP to TCP and all those things, my 136 bytes could be segregated like this. Okay, and in turn MQTT publish header. So these are the different size of the request and response. And for the acknowledgement, it is 81 bytes. Let's move quickly for this. And then I have a subscriber header and subscribe acknowledgement. And then we had just to analyze the latency and Same thing goes with COAP protocol. I think we can move faster with these slides because this gives you the header structure or the protocol structure. COAP, the application protocol, and at the below at the presentation layer, I am going to use DTLS, that is the datagram, transport layer, security, and below that I am going to make use of UDP. COAP uses UDP, and then at the below layer, that is your DTLS, which is a combination of COAP and UDP, and at the network layer is the IP routing protocol, followed by the data link layer or Wi-Fi or the Ethernet. And then how you quantify, I'll just quickly move to that. So this is related to HTTP protocol, where you are going to exchange the data between the client and the server. And then the TLS protocol below that, which is used for encryption or the security purpose, and the transportation protocol is the TCP, followed by the network layer protocol, or it is IP, and then we have data link and the physical layer. And this is the summary or the statistics what you get. So when you analyze this, at the transport layer, your TCP header for MQTT is 32 bytes because your MQTT, we said it is reliable and it uses TCP, whereas here at COAP it uses UDP, which is 8 bytes, and your HTTP uses 32. And then the total size, see, it is a huge size of 80 bytes, which is intermediate 54, and it is again 221 bytes. So if you see the response time or publish response header, we better prefer to go with the COAP protocol, which is 7 plus 58 bytes, than go to with MQTT and lastly with HTTP, which is 136 plus 58 bytes. So it based on our analysis which application we want, then you are going to decide on what kind of protocol or the performance summary. And now coming down, we have studied so many all theory concepts, so many all protocols. Even in the first session, we have seen the sensor, it sends the data, receives, you connect so many all sensors, isn't it? The light sensor, temperature sensor, whatever it is. Now, as a first time user, if I get an Arduino board, which has some cost involved in that, I have a Raspberry Pi, and I have all the sensor. Is there any possibility of the device getting wear and tear down, burned, something like that? Or every time is it a smooth execution of your IoT devices? Isn't it? Always we will have here and there some devices get burnt, your breadboard we use, isn't it? So when we want to connect. So instead of experimenting ourselves directly with the devices, so you can also make use of the software, which is again freely available. Maybe you would have heard about this. It is Tinkercad. I would not be able to demonstrate since we are not in the lab. So Tinkercad, if you just Google it, you have your mobile phone, you can just Google that Tinkercad. The first link which you get, you can open that. Again, it is an open source. You need not pay anything for that. It could be linked to your Google account because there should be some account. Minors would not be allowed. It could be connected, linked to your Google account. Just anybody, if we could try it out, then I could show you. I don't think I have a screenshot of that. No. Anybody who could try out that at your end? It could be linked to your Gmail account, and then you will get, you have there multiple options. You can select circuit there. If you select that circuit, maybe sir in the laptop or in your system it could be a bigger one. Circuit if you open, you would be opening with a working workspace there, and at the right side you will have all the components which are required for IoT. All the components, maybe it is from LED to your temperature sensor to the Arduino board, breadboard, the connection links. Each and every component could be available on your right side of the workspace. You can just drag and drop them, and only thing is you need to know to connect them. What needs to be connected to what? Like you should know what the details now. If you see in the morning session, there was an Arduino board which was displayed. You had certain configurations, isn't it? Which is ground, which is 5 volt, which are the input, which are the output port. That minimum requirement should be known so that from what to what you need to connect. Everything is drag and drop option there. I just need to drag and place everything in place, connect to them. And then you have an option where the code is generated automatically for you. So it's not a good idea for the students to use it. You should also know how to code it. Okay, so the code could be generated in that. And then you have an option called run simulation or start simulation. Some option is there. If I think, are you able to open that? Yeah, okay, you can try it at your end. So that's one of the nicest tool which you can play around before actually implementing on the real-time objects, because everything involves cost. So try on Tinkercad. If it is working, then implement the same thing on the hardware environment. That's a small suggestion which you could take up. And then I hope at least one or two could open that tool. Okay. Fine. So these are the differences between, since we are running out of time, I think this could be manageable, because since we have gone through all this protocol, what are the major differences between the AMQP and then MQTT and then the WebSocket, where mostly this MQTT is used. MQTT is, I mean, very popular, which is, you might have heard about that, Amazon, the Bosch, we have IBM, they all make use of MQTT. And then AQMP, Google, the company JP Morgan, and NASA, they are popular in using this AMQP protocol. And then COAP, your Intel and the Cisco, when two known companies for networking, they make use of COAP protocol. And DDS, it is used by Local Grid or Volkswagen. And then these are few references which I have referred in preparing this presentation. I think, thank you for your patience listening. I hope I would have made some sense.
Thank you, ma'am, for sharing your knowledge. We appreciate all the valuable insights you have provided.
I would like to request Ashwini Gaudi ma'am to present the moment to our today's resource person, Dr. Bhagyashree R. Hanji. Thank you, ma'am. Now I would request everyone to follow for lunch break. We shall be back after